So last year in Texas, we had an ice apocalypse, and it decimated all the trees in Austin. I'm exaggerating when I say all the trees, but my trees were decimated. All the trees I had in my backyard basically collapsed from the weight of all the ice. And my fence was completely destroyed, and my workshop was basically destroyed. So we couldn't rebuild the fence because the old workshop was on the wrong easement. So we had to demolish the workshop. That meant that all my projects that I had been working on had to stop. And one of those projects was the lap steel. So last year I started the lap steel project. I did a video on the design process in CAD. I even glued up the stock. So the stock was completely finished, ready to be machined, but I had to stop all projects. So this workshop was built, and of course I needed to move all my tools in. I needed to get acclimated to the shop. And that's what we're picking up. We're picking up after last year's hold on the lap steel project. So let's go ahead and take a look at the stock. Let's put it on the machine and let's build that lap steel. Let's finish this project. Let's get started. So I had done all the CAD work and I did the glue up on my blank here. So it's a piece of alder and it's got this kind of centerpiece, and I put some alder wings on it. So my CNC table's not big enough for this lap steel. So I can't fit it normally on this table. I need to fit it diagonally. And in order to do that, what I need to do is draw a center line diagonally, 45 degrees onto this waste table. So I'll place the lap steel blank on the center line this way, and I'll have enough room to machine it. So this is just a mock-up, but you can see I have the center line of the stock essentially on this diagonal center line. And so all I need to do is clamp it down. Ready to go. Let's do it. This is a unique and interesting way to machine an instrument that's too long for your CNC machine. I'm actually machining it diagonally. So right now, this stock is way too long to fit on this axis like this. So what I had to do was make it diagonal. And this is actually not that hard to do and actually pretty accurate. So you'll notice I have a wasteboard here. So what I've done is I measured from this point of the wasteboard to this point. And what I've done is I've drawn a diagonal line from this point to that point. And that diagonal line is my new center line. Now I draw a center line on the stock and I align that center line with this diagonal line on the wasteboard. And I ensure that the very tip of that center line is meeting the very tip of this wasteboard. So now all I need to do is measure from the center of the wasteboard, which is right here, to that point, and I can set my origin point in my CAM software to right here. So the X, Y would be like this, like a normal X, Y, and that's my origin point. But because my measurements are from here to here, that's where I know my stock is at the end, and I know my stock beginning is at the other tip, the CAM software just figures it all out. It's all just perfect math. And so it's a really great way for anybody with a smaller CNC machine to take advantage of their diagonal line here, which is much longer than your Y or your X. right, so I finished the hog out and the finishing pass for the wings. And then I did the route for the P90. So I will be putting a single P90, and there's my P90, and there's the routes. Everything's looking really good. And obviously this is alder, so you can see the seam for the wings because it's just a different grain pattern and color of the wood. But this is going to be painted, so it's alder. It does not look good stained. It's a very nice alder. It's very lightweight, but really what you want is a solid color. So we'll probably be doing like a sunburst on this, just like the fairy tales. So this is what it looks like right after the adaptive hog path. So this is essentially just removing as much material as possible in the most efficient way. And what it does is it leaves these steps. So when we run the finishing pass with the ball end, it'll actually remove all this material. So what I do is I have it leave about 0.5 millimeters of material on the X and the Y. And so it'll come in at a 45-degree angle and start finishing off. And the step over is about 0.6 millimeters, something like that. I can't remember. But it's enough of a step over to really reduce the cusps, and it allows me to not have to do as much sanding afterwards. That's my ball end mill right there, the Spectra bits. And it's a little dull, but I found that once these get duller, they actually leave a better finishing pass. That's just my opinion. But I've had this one for years and I haven't replaced it, even though it is quite dull, but it's actually doing a great job. Finishing pass does a great job, so not a lot of sanding necessary. P90 route. Holes for the knobs, they just go down about 10 mil. There's our nut line, and here's the 8.1 degree break angle. And I have PEC drilling for the tuner hole placements. It was a very lovely lap steel. Alright, so this lap steel just came off the CNC table, and we've done all the machining for the top, and it's looking like $1 million. So I'm really happy with the way it came out. I decided to do the pickup route. I wasn't going to at first because I didn't know what kind of pickup I wanted, but decided on the P90. It makes a lot of sense. Here's my thought process on the P90. It's got the bite you need for lead work. But you have your tone knob so you can kind of roll off the tone and get some kind of warm sounds if you need to warm it up. One pickup, it's just really simple. I centered the pickup because right now I'm kind of guessing where the bridge is going to go and where the benders are going to go. So this is essentially sort of in the middle. So it's like a middle pickup in between the fretboard at the end and the bridge. And I've centered it between the two knobs, so it's going to look kind of cool. I did the knob route, so these go down about 10 millimeters. And then I did the headstock. So when I initially designed this, I designed it with a 7-degree headstock break angle, and I kind of pushed it to 8.1 degrees, just like the look of it. And I did do some PEC drilling for the tuner holes. So keep in mind, while it's on the table, this headstock is basically angled. So the router bit coming down perpendicular to the table can't really make a proper hole. So all I do is do a 2 mil PEC drill, so it points out exactly where I need to drill the actual tuner holes on the drill press. So now all we need to do is do the back. Now, typically on a build like this, you do locator pins, right? On the center line, and then you'd flip it, and then you'd kind of set it down on the table. There's really no need to do any type of precision locating on the back. The only machining we need to do is for the cavity. Now the cavity, really, we don't really need precision as to where it goes. It can actually be off by 0.2 millimeters in any direction on the Y or X. So all I'm going to do is use the center line as a locator origin, ensure it's on the center line of the table, and it should give me really precise location for where that cavity should go. Put the cavity in, which is really just hogging stuff out. And then we can do the hogging out of the headstock back. Really easy, so all we gotta do is put this back on the table and start the machining of the back. All right, so we need to machine the back of this stock, and there's no locator pins. Traditionally, you would put locator pins on the center line, you flip your stock, and then you can machine your back with perfect precision. And I didn't want to do them because I thought that the back machining processes didn't require any precision. For this, what we want to do is just make a center line. So I printed this out. So what I can do is I can cut this out, align it, and then I can put my center mark where it should go on the headstock. So let's go ahead and cut this out and transfer it. My drawing that comes from CAD that I print out to a 1-to-1 ratio is perfect. And then this is obviously the machine that's been done by the CNC, so everything just lines up so well. Mag routes in, so these are just tiny little pockets for the magnets. I'm using just 3, 1, 2, and 3, and there won't be any magnet here in this far end. 3 should hold it in place. And I'm going to probably use acrylic for the cover. I don't use wood anymore for control covers. Wood looks totally cool and killer, but this thin, which is about 3 millimeters, that wood's going to deform over time. 100% it will deform. So what I want to do is use acrylic, and it'll be a really cool looking acrylic that we use. And of course, we talked about this in the design phase, where I was able to route this cavity and push it far enough towards the center to expose the route of the P90. And this allows you to actually route the wire this way. So as you know, a P90 pickup is routed with 2 wood mounting screws in the actual posts. So it's not routed on the wings like normal humbuckers. And so we can take advantage of that. And instead of having to drill a hole manually at an angle, all we do is just machine the cavity into the P90 route, and that exposes this little corner, and we can wire our wires this way. All right, so the lap steel is removed from the frame. And all I did to do that was basically cut through the tabs using a oscillating tool. I've shown this 1,000 times on all my guitar body builds. I don't need to show it again. And then use a trim router to kind of like use that flush bit and pattern bit and just remove the tab. At that point, once you sand, it's invisible. You never see the tab was there. But I haven't sanded this yet. This needs to be sanded. And this is the point of the build process that I kind of don't like. I wish I had an intern, an intern, an unpaid intern, who could come in the morning and do all my sanding. There's a lot of things in the guitar process that luthiers don't really need to be involved in. Like, for example, I removed this from the frame with an oscillating tool. I used a trim bit router to remove the actual tab left over. A guitar builder doesn't need to do that. I mean, an intern can do that, or a team of interns. So yeah, sanding. Obviously, I'm gonna do that off camera. But what we do need to consider is what we're gonna be doing at the finish. I have no clue. This is alder, so it is a very plain looking wood, and it is a tight grained wood. So I mean, we could stain it, but there's really not going on with this grain. And there's a few knots too that show through, and so it's not a very pretty wood, and it was never really meant to be. I wanted to do something like the Duesenberg Fairytale and do like a sunburst or like a wine burst, something with some magentas maybe. I don't know. A burst was always in the back of my head. Solid colors were always in the back of my head, but that's just an idea. You let me know. What should we do? Should we just go some of the candy colors? You know, the 50s car type colors? Solid? Should we just stain it? I don't know. But that's the fun part. That's the part where we get to sort of explore, and we get to kind of like really push our imagination and try to figure out something that's gonna be cool. And then fretboard. Fretboard is also gonna be a really cool, fun challenge because I don't want to use wood. What's the point, right? Where our fingers are never touching the fretboard on a lap steel. The Duesenberg Fairytale uses an aluminum fretboard. I think that's a fantastic idea. So I want to use an alternative material. I'm really not there yet. I don't know what I want to use. I have a ton of Richlight left over too, but Richlight's black and it's kind of boring. I want to do something colorful or something kind of unique and classy. Anodized aluminum sounds about right. We'll see. I haven't made that decision yet. So at this point, I think we're gonna just call it. The husk of the body's done. If you're interested in these bodies, on my store, I have plans and drawings for this body. So I have the 1:1 ratio scale PDFs of these drawings that were basically exported from CAD, so they are perfectly precise. I also have some digital files. So if you have a CNC or a 3D printer, there's some digital files available. And there you go. Here it is, the Fairytale Duesenberg inspired guitar. Mine has a really cool volute. Check that volute out. All right, nice. All right, thanks for watching. Take it easy.